In this video, I'm going to be talking about some basic graphing techniques. So all the way back to the beginning here, a point is made up of an ordered pair. An ordered pair are two numbers written in a parentheses. We usually write the x-coordinate first, or we always write the x-coordinate first, comma, followed by the y-coordinate. We can use that information on a table or a graph to represent a point on the graph. So for example, here's our coordinate plane. We break up a coordinate plane into four coordinates. Coordinate 1 is in this top corner over here, and then we're going to go counterclockwise to give us coordinate 2. Coordinate 3 is over here in this corner, and then finally coordinate 4. The middle point is the origin of our graph, located at 0, 0. It's the beginning of the x-axis and the beginning of the y-axis. Speaking of the x-axis, that's the horizontal axis, so x is 1, 2, and 3 are here, and negative 1, 2, and 3 are here. And then our y-axis is vertical, going from positive y values to negative y values at the bottom. Okay, and then if we were to plot a few points, we can plot point A, B, and C. Point A is positive 5, 6, so I'd start from the middle and count out 5 in the x direction and 6 in the y direction. I don't know why I picked a point off of the graph, but there you go. Point A is up here. Point B, we can say, is negative 2, 1. So that's negative 2 in the x direction. So starting at the middle, we're going to go left, 1, 2, and up 1 to give us point B. Notice that I'm labeling them with capital letters on the graph. And then finally, let's do one that's in quadrant 3 with both negatives, so negative 1, comma, negative 4. We're going to go negative, left 1, and down 4 spaces to give us point C. So that's, if you'll remember, that's how the coordinate plane works. And from there we can graph lines, equations, all different shapes of functions, as long as you use a table of values to plug in for the missing variables. So for example, if I give you, I don't know, let's say our graph, our function is y equals 3x minus 1. You can graph this by the y-intercept and the slope. But if you don't remember what the function looks like, you could also make a table. So let's just pick any points, and everybody asks me, where did I get these points? It doesn't really matter what points you use. If you get an undefined answer or an answer doesn't work, then just try a different point. The best points to try, negative 2, negative 1, 0, 1, and 2. This will give you a look around the origin so you can see kind of a snapshot of what the graph looks like. So what we're going to do is take your x value and plug it into the equation, and that'll give you your output value, your y value. So we're going to plug in negative 2 here, and that is negative 6 minus 1, which is negative 7. If I plug in a negative 1, it gives me a negative 4. When I plug in 0, you have negative 1. And then you're just going to continue to plug in these points to find your corresponding y value. So plugging in 2 here gives me 5. So now we have the x values and the y values. I could graph those points, connect them on the graph, and then have an accurate, in this case, linear function. Oh, of course I didn't make my graph big enough though, so we're going to go, doesn't fit, -1. At 0, we're at -1. At 1, we're at 2. And at 2, we are at 5, which doesn't fit. And then we're going to use a straight edge and connect your graph. Make sure to use arrows at the end because this is a continuous function. It's going to continue in those directions.